Hi students, in the previous video I discussed about how we can identify cations and also what is chemical analysis and what is qualitative and quantitative analysis. In this video I am going to discuss about how we can identify anions. Please keep watching. Identification of anions. How we can identify anions. Anions are negatively charged ions, or they are identified using acids, so they are also known as acid radicals. Anions are also known as acid radicals. Now, what are the ions to be identified? In class 10, we have 6 anions, that is carbonate ion, CO3 minus minus, sulfide ion, S minus minus, and sulfite ion, SO3 minus minus, and chloride ion, Cl minus, nitrate ion, NO3 minus, and sulfate ion, that is SO4 minus minus. Now, we have the anions grouped into different groups. That is, first we have the 3 anions, carbonate, sulfide and sulfite are categorized as dilute sulfuric acid group because they can be identified easily with the help of dilute sulfuric acid. The next 2, chloride and nitrate, are categorized as concentrated sulfuric acid group because they do not react with dilute acid, they react with concentrated sulfuric acid. And then the last one, that is sulfate ion, is known as a non-acid group because it does not react with acids. So now let us go into detail how we identify each one of them. So what is to be done first to identify the anions? The preliminary test, test number 1, or the first test to be performed is, take a small amount of the given substance in a test. You can add dilute sulfuric acid to it. Now if no reaction happens, you may heat it. Okay. Now what are the possible observations? Observation 1. The first observation is colorless and odorless gas evolved. This is possible. And the gas extinguishes a glowing splint. The gas turns lime water turbid or milky. And the milkiness disappeared when excess of the gas is passed through lime water. So these are the qualities of the gas. A colorless, odorless gas evolved, which gives these tests. And the gas had no action on potassium dichromate paper. If you dip a filter paper in potassium dichromate solution and introduce to the gas, nothing happens. So these things clearly help us to understand that the gas is nothing but carbon dioxide. What is the gas? It is carbon dioxide. It is colorless, odorless, extinguishes glowing splint, turns lime water milky or turbid, no action on potassium dichromate paper, carbon dioxide. If carbon dioxide is evolved when dilute sulfuric acid is added to a substance, what does it mean? The anion present is carbonate, CO3 minus minus, right? That's very simple. Now, when you add dilute sulfuric acid to the substance, if these things did not happen, some other observation is possible. The second observation that can happen when you add dilute sulfuric acid to the substance is a colorless gas with an unpleasant odor. You don't like that smell. It's the smell of rotten egg. Such a bad smell comes, a foul smell comes. The gas also turns lead acetate paper silvery black. If you dip a filter paper in lead acetate solution, introduce to the gas, the paper will turn silvery black. Black at the same time shiny, right? So the conclusion is the gas evolved is hydrogen sulfide. Hydrogen sulfide. Formula is H2S. That means the anion present is sulfide. Anion present is sulfide, S minus minus. So that is clear. Now when you add dilute sulfuric acid to the substance, another observation is possible. The third observation is a colorless gas with a pungent odor of burning sulfur. It's very pungent, it pierces your nose if you breathe. So it's a poisonous gas. And this gas turns lime water milky. Like carbon dioxide, this also turns lime water milky. And one more test we will perform with this gas is the use of the potassium dichromate paper. Milkiness disappears in excess, all that is same like carbon dioxide, but this is a different one. That is, the gas turned potassium dichromate paper green. You dip a filter paper in potassium dichromate solution, introduce to the gas. The potassium dichromate paper is usually yellowish when dipped in the filter paper dipped in potassium dichromate. But when introduced to the gas, it turns green. That shows the gas is sulfur dioxide. What is the gas? Sulfur dioxide. Formula is SO2. So the anion present here is sulfite. Sulfite. SO3 minus minus. right? I think this is clear. So these three anions are identified, that is carbonate, sulfide and sulfite are identified with the help of dilute sulfuric acid. Okay. Now what are the reactions possible in this? If you take let us say Na2SO3 sodium sulfite, it reacts with dilute sulfuric acid H2SO4. What is the reaction possible? Na2SO4 sodium sulfate plus water and sulfur dioxide. This we have already studied under acid bases salts. Yes, same way in the previous one, if you see sulfide, in the case of sulfide we have the, if you take sodium sulfide Na2S and it is reacting with dilute sulfuric acid, okay, what will come? Na2SO4 sodium sulfate plus H2S gas, hydrogen sulfide is possible, right? Similarly, in the carbonate case, if you take the carbonate, sodium carbonate, Na2CO3 plus H2SO4 dilute sulfuric acid is added, what you get? Na2SO4 sodium sulfate plus water plus carbon dioxide. So carbon dioxide gas is here, it means carbonate. Hydrogen sulfide gas comes, that means it is sulfide, and if it is sulfur dioxide gas, then it is sulfite. Okay, this is about the dilute acid group. Now we have the second preliminary test. This is for the anions which are identified by concentrated sulfuric acid. We take another test tube, a small amount of the substance. Now we will add concentrated sulfuric acid and heat. What happens? Two observations possible. First one is a colorless gas with a highly irritating or choking odor. It will pierce your nose and you will not be able to breathe, suffocating, and you will cough. Such a coughing and sneezing gas comes out, and the gas turns, it gives a dense white fumes. The gas gives, not turns, or turns to, you can write, or gives dense white fumes when a glass rod dipped in ammonia solution. Ammonia solution is ammonia dissolved in water, which is NH4OH, ammonium hydroxide. It gives a dense white fumes. That means the gas evolved is hydrogen chloride. What is it? Hydrogen chloride gas. HCl is a formula. So this gas is evolved means the anion present is chloride. What is the anion? Chloride, Cl minus. It is concentrated sulfuric acid group. Example, if you take sodium chloride, react with concentrated sulfuric acid, what you get is NaCl, sodium chloride plus, sodium chloride, NaHSO4, sodium hydrogen sulfate or sodium bisulfate plus HCl. Hydrogen chloride gas is evolved here, you see. So you can identify it as chloride. Now the other observation possible when you add concentrated sulfuric acid to the salt and heat is, if it is not a chloride, then another possibility is there will be a, it is here, gas, a reddish brown gas is evolved. Reddish brown gas with a suffocating odor. This also chokes your respiratory system. A reddish brown gas with suffocating odor is the second possibility. Now this gas also can be tested with other testing reagents, like if you take a ferrous sulfate solution which is pale green and pass the gas through it, it will turn the pale green solution to black, and then the gas also turns the starch iodide paper, which is a white colored paper, will turn to blue black. A bluish black color will be formed. This clearly shows that the gas is nothing but nitrogen dioxide. What is the gas? Nitrogen dioxide. So the anion present is nitrate. What is it? Nitrate, NO3 minus. So what can be a possible reaction? If you write here, if you can write sodium nitrate, NaNO3 plus concentrated H2SO4 sulfuric acid will give you NaHSO4 on heating, will give NaHSO4 plus HNO3. Now HNO3 is unstable, will decompose because of the heat to give H2O plus NO2 plus O2. So 4 and 2, 4. Yeah. So nitrogen dioxide is evolved, which is giving the reddish brown color. Now next thing to note is, suppose the substance is not reacting with dilute sulfuric acid or even with concentrated sulfuric acid. That means none of the ions mentioned above is present, that is carbonate, sulfide, sulfite, then chloride and nitrate. All of them are absent, they are not present. Now it is assumed that because they are absent, that the substance contains what? Sulfate ions. It contains sulfate ions because sulfates don't react with acids. Okay, so it is identified as sulfate ion. So we need to confirm this. So we have some confirmatory tests for each of these ions, right? For carbonate ion, the same test. Dilute sulfuric acid with the substance, colorless, odorless gas evolved, turns lime water milky, and the milkiness disappears when excess of gas is passed, and no action on potassium dichrome paper. If these things are there, carbon dioxide gas is evolved from the substance, it is confirmed that the anion is a carbonate. Then sulfide ion, the confirmatory test is substance plus dilute sulfuric acid, which we already discussed. Unpleasant smelling gas comes, rotten eggs, and it turns lead acetate paper silvery black. This shows that it is a sulfide radical. The gas evolved is hydrogen sulfide. For sulfide radical, the confirmatory test is when dilute sulfuric acid is added to the substance, it gives out a gas. The gas is colorless, pungent odor is there, sulfur dioxide gas. It turns potassium dichromate paper or solution to green. So that shows it is a sulfide radical. Now another confirmatory test for sulfide radical is you can make aqueous solution of the substance, dissolve the substance in water, and then add barium chloride solution to it. What do you get? After adding barium chloride solution, you must also add dilute hydrochloric acid to it. So what happens? First, a white precipitate comes when you add a barium chloride solution. Now the precipitate will dissolve when you add dilute hydrochloric acid. This shows it is a sulfide radical, right? Now for chloride radical, the confirmatory test is to make aqueous solution of the substance and then dissolve, add silver nitrate solution to it. You will add silver nitrate. What you get is a curdy white precipitate. Curdy, the precipitate looks like curd. Curdy white precipitate, PPT is precipitate. Correct spelling is PRECIPITATE, precipitate. Okay. And for nitrate radical, what is a confirmatory test? This is called the ring test. It is called a ring test. This needs to be done very carefully. First, you will make aqueous solution of the substance, 2 milliliter of the substance in a test tube. Aqueous solution, how do you make? Take the salt, add some water, shake well, it dissolves, that is aqueous solution. Okay. Then, equal volume of freshly prepared solution of ferrous sulfate. It is prepared in another test tube, it is added to this, right? Then, tilt the test tube and through the sides, you will add a few drops of concentrated sulfuric acid. And don't shake the test tube. Test tube should not be shaken. Now you will cool the test tube. After a few seconds, you will find a dark brown ring coming at the junction of the two liquids. What are the two liquids? Aqueous solution of substance and aqueous solution of ferrous sulfate, right? In between the two solutions, you get a dark brown ring. This is a confirmatory test for nitrate. Then for sulfate, similar to that of sulfite, aqueous solution of substance is made, adding barium chloride solution to it and then adding dilute hydrochloric acid to it. Same test we did under sulfite also. But what is the observation here? This time again white precipitate formed, but the precipitate does not dissolve in dilute hydrochloric acid. Understood? In the case of sulfite, the precipitate dissolved when you added dilute hydrochloric. Here the precipitate is not dissolving, so it is sulfate radical. That is the confirmatory test for sulfide radical. So students, I hope you understood how we can test for anions, the various anions, and what are the confirmatory tests for this. So you can like the video and subscribe the channel so that the further videos that I upload you can come to know. And in the next sequence, I will be doing other practical tests under analytical chemistry, identification of copper oxide and manganese dioxide, and also reaction of alkalis, and how to distinguish between acidic and alkaline solution. So continue watching and subscribe. Thank you.